Hello students. So in the previous video we discussed the various theories of light, namely Newton's corpuscular theory of light, Huygens mechanical wave theory of light, the third one Clerk-Maxwell's electromagnetic theory of light. And this Clerk-Maxwell's electromagnetic wave theory of light could explain all the properties of light except photoelectric effect. And this last property, photoelectric effect, can be explained on the basis of Max Planck's quantum theory. According to Max Planck's quantum theory, the light energy is given out in the form of packets of energy called quanta or photons. So that part we discuss in detail. Last year in the PUC first year chapter views, you have studied the characteristics of waves as well as the properties of a wave motion, characteristics of wave, speed of wave, time period, wavelength, frequency and phase. These are the various properties of the characteristics of the waves. As a wave propagates through a medium, particles of the medium vibrate about their mean position. Then these particles have both velocity and acceleration. Mechanical waves, non-mechanical waves. Mechanical waves are waves to propagate through a medium is a must. There is a necessity of a medium for waves to propagate. For example, sound waves, waves over the water surface. When you disturb the calm water surface, circular ripples are formed over the surface of the water, and these circular ripples advance away from the point of disturbance. Hence, the waves over the surface of water are transverse waves, waves formed in strings. When a stretched string is plucked, the waves are formed in the whole length of the string. So medium is necessary for the mechanical waves to propagate, whereas the non-mechanical waves, there is no necessity of medium. The electromagnetic radiations and light are the examples, and they can travel even through vacuum, and they are the transverse in nature. Mechanical waves, the particles of the medium vibrate about their mean position. Waves travel along a x-axis. Different particles are at different positions from the origin, and displacements are different for the particles, but the amplitude of the wave is the same. Particles of the medium vibrate in a direction perpendicular to the direction of propagation of waves. Such waves are called as transverse waves. Longitudinal waves, the particles of the medium, as sound travels from one end to the other end. Let us consider sound traversing along x-axis. The particles also vibrate in a direction same as the direction of propagation of a sound. The air particle, the medium particle, they vibrate in the same direction as the wave propagates. Hence, they are the longitudinal waves. So sound waves are longitudinal waves, whereas the light waves are transverse waves. Transverse waves can be polarized, longitudinal waves cannot be polarized. So we have discussed in detail the Huygens wave theory of light. In case of Huygens wave theory of light, the energy and momentum are transported in the form of a mechanical wave from the source, away from the source. Light is a transverse mechanical wave according to Huygens wave theory of light, requires medium such as air water string. The equation of the wave, mechanical wave traveling along x-axis is y equals to a sin omega t minus kx. Y is a displacement, a is amplitude, omega is a frequency, k is a propagation constant, x is the direction in which the wave propagates. And this wave theory could explain all the properties of light except photoelectric effect. But this theory failed uh, or rejected because according to this theory, then there is a necessity of a medium. Without medium the waves cannot travel. But experimentally beyond doubt it has been proved that the light can even travel through vacuum. Hence this theory was rejected. Later it was Clerk Maxwell proposed electromagnetic wave theory. According to him, light traveling along x-axis consists of both time varying and space varying electric field and magnetic field perpendicular to each other and also perpendicular to the direction of propagation of light. So both E and B are perpendicular to x. Transverse waves, actually the Clerk Maxwell, he developed four equations, and with help of four equations to describe the laws of electricity and magnetism, with the help of those equations he established or developed another equation called the equation of the wave. And it was Clerk Maxwell predicted the existence of electromagnetic wave based on the equations what he developed. The equations are: transverse electromagnetic wave, electric field is E equals to E naught sine omega t minus kx. This is the equation of the wave for electric field. Magnetic field, B equals to B naught sine omega t minus kx. These are the wave equations. So we first he developed these wave equations and predicted the existence of electromagnetic waves. This Clerk Maxwell's wave theory could explain all the properties of light, that is rectilinear propagation, reflection, refraction, dispersion, interference, diffraction, but it could not explain the photoelectric effect. When a light of suitable frequency made to incident on a suitable metal, electrons are ejected out from the surface of the metal called photoelectric effect. And this photoelectric effect, this particular property of light, could not be explained on the basis of Clerk Maxwell's wave theory, Huygens wave theory, even Newton's corpuscular wave theory. Then fourth theory of light was emerged, that is Max Planck's quantum theory of light. According to Max Planck's quantum theory of light, the light energy from the source is given out or emitted in the form of packets of energy called quanta or photon. Actually, Max Planck named them as a quanta. Later it was Newton who called these quanta as photons. Energy of photon or a quanta is given by E equals to h nu. H is a Planck's constant, nu is a frequency. So energy, the light energy or electromagnetic energy, light energy is given out in the form of packets of energy called quanta. This is Max Planck's quantum theory of light. So Max Planck's quantum theory of light can explain only the photoelectric effect, but fail to explain the other properties of light. Hence, those days it was accepted that light has dual nature, both wave nature as well as particle nature. So depending upon the situation, we can consider light as a wave theory of light. In order to explain interference and diffraction, we have to consider light as a wave theory, or light energy is propagated as in the form of waves. In order to describe the photoelectric effect, we go by Max Planck's quantum theory of light, that is a particle theory of light. So here Newton's corpuscular theory, Max Planck's quantum theory are particle theory of light, whereas Huygens wave theory and Clerk Maxwell's wave theory, they are the wave theories of light. Hence light has the dual nature, both particle and wave nature. Further, we discuss the Huygens principle. So in this particular chapter, we are going to discuss in detail both interference and diffraction on the basis of a Huygens wave theory of light, that is Huygens principle. When we drop a small stone on a calm pool of water, waves, that is disturbance, that is circular ripples, they move away from the point of disturbance over the surface of the water. So here the source, these are the circular ripples. There are alternate crusts and troughs. These disturbances move away from the point of disturbance. So disturbance set up due to oscillations of water molecules. Water molecules, they vibrate about their mean position up and down, whereas the circular ripples move over the surface of the water. So here water molecules execute a simple harmonic motion. The waves travel in all possible directions with the same speed. The speed of the wave is given by V equals to F lambda, that is a product of frequency and a wavelength lambda. The disturbance from the source S reaches to all the particles which are equidistant from the source simultaneously. Then all these particles, they are vibrating in the same phase. The particles vibrating in the same phase means the position of the particle from the mean position and direction of motion of the particle for all these particles is the same. If this particle is at the extreme position from the extreme position, then all other particles are also at extreme position. And if one particle is at a mean position and expected to move in downward direction, then all other particles are also at a mean position and expected to move downward position. So all these particles which are equidistant from the source get disturbed simultaneously. Okay, these particles do vibrate in the same phase. Then a locus of all these particles, locus of all the particles vibrating in the same phase is called as a wavefront. Here ABC is a wavefront, circular wavefront, as in the case of waves produced over the surface of water. And these wavefronts are not localized, they do not remain there itself, they travel away from the point of disturbance. Thus wavefront is defined as the surface of a constant phase. Phase of the particle gives us its position of the particle as well as the direction of motion of the particle with respect to the mean position. So water waves are two-dimensional since they travel over the surface of the water, whereas the light waves are three-dimensional. If you consider a point source, then the light energy from the point source travel in all possible direction, hence it is distributed three-dimensionally. Light energy is distributed three-dimensionally from a point source. The energy of the wave travels perpendicular to the wavefront. So refer to this particular diagram here. S is the light source. Light energy is transported in the form of transverse waves. Alternate crusts and troughs are present in the disturbance. The wave travel with a constant speed, then the particles which are equidistant from the source, they get disturbed simultaneously. Then all the particles which are equidistant from the source, they vibrate in the same phase. then a locus of all these particles vibrating in the same phase is called wavefront. So it is a diverging spherical wavefront in case of light. Okay, in case of light, don't consider these as circles, they are the spheres. Since light travels in all possible direction, then a locus of all the particles vibrating in the same phase is not a circle, it is a sphere. Hence this particular sphere at a given instant of time is called as spherical wavefront. Diverging spherical wavefront. All these are spherical wavefront at a different instance of time. When these, suppose if I take this source as a sun, and nearby the sun the wavefronts are spherical wavefronts. As these wavefronts traverse through infinite distance, if these spherical wavefronts, when they reach earth, when they reach earth, what happens? The curvature of these spherical wavefront goes on decreasing, traversing through infinite distance. Thereby the spherical wavefront change into plane wavefront. So as the radius of these wavefront increases, the curvature of the surface decreases, the wavefront traversing infinite distance. So the sunlight reaching to the earth, the nature of the wavefront is plane wavefront. So wavefront rays are always perpendicular to the wavefront. These are the rays perpendicular to the wavefront. Here also the rays are perpendicular to the wavefront. So the bundle of rays what we receive on earth from the sun is a parallel beam of light, we say, and the nature of the wavefront is plane wavefront of light. Wavefront. The waves or disturbance from a point source travel with the same speed in all directions. The particles which are equidistant from the source get disturbed simultaneously and vibrate with the same amplitude and phase. The locus of all these points having the same phase is called spherical wavefront. Instead of a point source, if you consider a linear source, the tubeless is a linear source. Now considering the linear source, the light traverses in all possible direction. Then here the particles, these are the particles, they are equidistant from the source, hence they get disturbed simultaneously, and the locus of all these particles vibrating in the same phase is a cylinder, and the wavefront is named as a cylindrical wavefront. So this is cylindrical wavefront. When they traverse through infinite distance, the cylindrical wavefront get converted into plane wavefront. So both spherical wavefront as well as the cylindrical wavefront traversing an infinite distance, they become plane wavefront. So this is the case of linear source of light. Further, the Huygens principle. The Huygens principle is a geometrical construction to obtain the new position and shape of the wavefront at a later instant of time t. So this Huygens principle is based on some assumptions, three assumptions. So this is the source of light, this is the position of the wavefront at one time, this is the new position of the wavefront at a later time, this is the position of the new position of the wavefront at a later instant of time. So at a given instant of time, the position and the shape of the wavefront can be obtained by Huygens principle. Hence, Huygens principle is a geometrical construction to obtain the new position and shape of the wavefront at a later instant of time t. So, what are the assumptions? Number one, the particles which are equidistant from the source vibrate in the same phase or get disturbed simultaneously, vibrate in the same phase. The locus of all these particles vibrating in the same phase is a sphere called spherical wavefront. So here S is the source, A, B and C are the particles which are equidistant from the source. They get disturbed simultaneously. Locus of all these particles vibrating in the same phase is a sphere called spherical wavefront. The second assumption of Huygens wave theory of light is each point on the primary wavefront, here A, B, C is a primary wavefront, each point on the primary wavefront acts as a secondary source of light. A, B and C act as a secondary source of light, and from this secondary source of light travels with the same speed in all possible direction. Then the wavefronts from these secondary sources what we get are called as wavelets, and these wavelets also travel in all direction with the same speed. So first assumption is about a wavefront. Second assumption is each point on the wavefront acts as a secondary source. From these secondary source, secondary wavelets travel with the same speed in all direction. Third one, small spheres with a radius ct, that is a distance traveled in time t, are drawn from secondary sources as centers. The forward tangential surface or envelope touching all the secondary wavelets gives the new position of the wavefront at a later instant of time t. Hence A dash, B dash, C dash is the new position of the wavefront called secondary wavefront. Refer to this particular diagram here. A, B, C are the secondary sources. Taking these secondary sources as a center, small spheres, here small spheres, this is the arc of the sphere, with C as a center, a small sphere, here it is an arc, here also it is an arc. Small spheres are drawn. Those small spheres are called secondary wavelets. Then tangents drawn to these arcs, are a tangential surface touching all the secondary wavelets. A tangential surface touching all the secondary wavelets or forward envelope touching all the secondary wavelets gives the new position of the wavefront at a later instant of time t. So A, B, C, they get disturbed at time t equals to 0. A dash, B dash, C dash are the particles which are equidistant from the source. They get disturbed simultaneously at a later time t. Then the locus of all these particles vibrating in the same phase is also spherical wavefront. So here Ct is the distance traveled by the light from A to A dash, B to B dash, C to C dash. Since speed is a distance by time, or distance is speed into time, So the particles which are equidistant from the source, that is CT, they get disturbed simultaneously. They vibrate in the same phase. Locus of all the tangential surface touching all the secondary wavelets gives us the new position and shape of the wavefront at a later instant of time. Note, uh, Huygens said that amplitude of the secondary wavelets is a zero in the backward direction. This explanation was not satisfactory. Later, the absence of back wave is justified considering the average energy transfer from the source. So here, we refer to these arcs in a red color, as the assumption says that the light from these secondary sources travel in all possible direction, taking them as a center. Secondary wavelets are drawn, but the light advances in a forward direction or away from the source, not towards the source. So the transportation of energy in a backward direction is not to be considered, because the amplitude of the wave is zero for a backward wave. It was an ad hoc assumption made by the Huygens that the light always advances, light energy is always transported in direction up away from the point of disturbance. That's why backward wave is not to be considered. Later, it was justified by taking the rigorous calculations, stating the average transfer of energy away from the source of light. So this is all about the Huygens principle. It is a geometrical construction to obtain the new position and the shape of the wavefront, which is based on the three assumptions. Okay, make your own notes in connection with the different theories of light, as well as the Huygens wave theory, Clerk Maxwell's wave theory, electromagnetic wave theory, Max Planck's quantum theory, and Huygens principle. Okay, thank you.